Hello, today we will be going to talk about how Hermes store messages, sessions, and tool calls into the database. So for Hermes, it chooses SQLite to store everything. And so for SQLite, it has really powerful mechanism that is SQLite FTS indexing, and it helps Hermes to store, retrieve data efficiently and fast. So let's get into that. Today, I'll be writing as we go because I think it will help everyone clarify thinking. So today we have three topics needed to be addressed. The first one is what is inverted index. So before knowing about inverted index, we have to know what is forward index. So just imagine if you want to, like for the traditional database, if you want to query a thing, you might use select or from db where, for example, content like this, right? So it's actually querying, for example, black cat, cat food, or this will be matched. So this is match operator. But just think about it, it's actually not very efficient because if you use the match operator, it will read through the whole table. So it's actually ON complexity. So let's say you have 1 million rows, so it's just not very efficient. And so also for forward index, you can think of like the key is the document and the value is the words that you can have, like I have a bike. So these are the values, so you can think of like that. But for the inverted index, it's quite the other way around. So the key now is the messages, the content. So the key can be messages content, and the values is the document. So this is actually quite the opposite. For example, the key is I could show up in the document 1, document 2, etc. Right? So have showed up in document 1, document 2, and for is the same. But for bike, it can only show up in document 1. So actually, when a database tries to query, so it just needs to see where the back it appears in document 1, so you just go straight to document 1. This is actually how it works. So the complexity is O1. It's very efficient. It's just like a hash lookup. And the next topic, what is FTS5? So FTS5 is actually a virtual table, first of all. It's not a separate database. It's not an external service. It's just a table. So when you write create virtual table my FTS using FTS5 content, what happened is SQLite creates a set of hidden shadow tables that stored the inverted index and the metadata. Here is metadata. Here is the content. So you don't really query these shadow tables directly. You query the FTS5 virtual table with the match operator. So the FTS5 will just handle everything afterwards. So how FTS5 works in Hermes and a simple demonstration. So we're gonna get into this topic now. So how FTS5 works, right? This is very important. Let's think of the message table in any agent's like memory system. So what does the messages table look like for you? Think about it. It can have, like, for example, ID, right? It can have session ID, and the session actually means a chat. You can think like that. You can have a role. It could be user or AI. You can have like the content, actually the message itself, or the timestamp, right? So these are the like very essential things in the message table. So when you create this table, you create a message FTS table. This is actually how Hermes does in its system. So it creates two tables, messages table, messages FTS table. So for messages FTS table, it has two fundamental fields. The first one is the row ID. The second one is content. Okay, this is very interesting part. So row ID actually points to which row in the message table. Okay, and for the content, it doesn't really store the content. It doesn't store the user's message, because just think about it. If you store user's message, let's say you have 1,000 messages. If you store this 1,000 message in both tables, it will double. So it will create a pressure for your server, for your disk, right? So basically, this content points to these messages. This is very, very smart thing to do. Okay, let's get into example to see how Hermes actually handles the message input by the user. So let's say a user sent a message last year. It sent old message. My ragdoll is in New York. Okay, so ragdoll is actually a breed of cat, just to clarify on that. Okay, so what happens to this message? So what happened is, in the message table, it will create this message, right? So it will create a new value. So for the ID, let's make it up 101, session ID 701, row user, content this, right? And timestamp now. Okay, so you will insert this message into the table. Do you remember the message FTS table? So it will trigger the insertion in message FTS table. So it will trigger these things. So it will trigger 101 because the row ID is 101 and the content. Right? No, that's not end of the day. There's another magic it does here. It will do tokenization. What is tokenization? It will split this sentence into tokens. So it will do like this. My ragdoll is in New York. So it will do these things. And so each point to the document 101, 101, 101, 101. So this is actually what happened when you insert a message. And then now, a month later, a user queries another message. Let's say new message. It's, where is my ragdoll? Now, just think about it. What will happen to the backend? What will happen to the database? I tell you now. So first of all, the backend, it will filter the stop words. What is stop words? for example, the conjunction and but, the pronouns I, he, him, and article, for example, and the, and so on. These words don't really have meanings, so the backend will filter these words. And so what words left? So only ragdoll left, actually. So the SQLite will only handle the ragdoll passed by the backend. Okay, so it will match ragdoll. So what happened to the SQLite FTS? Remember, we already have an index here, right? So this will go straight into here. You will find its counterpart here, and it points to 101, so it will go straight to this message. So it will just return this message. Very simple, very efficient, very fast. This is how Hermes works when a user inserts a message. Right now, I'll be showing a simple demonstration of how FTS5 works. Right, so now we can take a look at the table. You can see this is exactly we talk about. We have message table, and we have ID, session ID, user message, timestamp fields, and we have message FTS. So you have message and you have content, point to the messages table, and we have a row ID. Usually we don't really store a message here, but here we just show here as an example. So now let's insert something. Let's insert the same we had. My ragdoll is in New York, and you can see the raw message, my ragdoll is in New York, and it's split into tokens. My ragdoll is in New York, and you can see here the FTS5 maps each token to the document 1. So this document actually refers to this this message. This home message is a document. So in document 1 is in document 1, ragdoll is in document 1, and so on. And now let's insert another messages. Insert my ragdoll. So now you have here the tokens, my ragdolls. They are stored in the second message, which is the second document. So they're pointing to here. And now let's use search. Let's find the ragdoll. Where is my ragdoll? Okay, let's pause here. Just think about it. What will happen next? Okay, now you can see. Let's look at from the start. So the raw query is where's my ragdoll, and it's split into raw tokens, right? And it will eliminate stop words like where is my will be eliminated because they don't really contain any information. And the only word it will be matched is ragdoll. And it's looking here, and you can see the full query. This table, this is a virtual table match ragdoll. And now here's the very important part. The two answers are found. So my ragdoll is found. My ragdoll is in New York is found. So why two messages? Why there are two? Because it matches the ragdoll. And here's another question. Why my ragdoll is prioritized? We will be talking about this in next video because it actually related to the BM25. It's the algorithm behind the FTS5. So here you can see all the terms are retrieved. The terms are ranked. Okay, so this is how things work. Right, thank you so much for watching this video, and hopefully you learned something today.